Because tables are a two-dimensional surface, it is tempting to think of interaction on tables in this way. However, typical use of tables is often much richer, and people frequently make use of the third dimension. People stack objects on top of each other. They store objects using their vertical position to save space. And they use multiple sides of the object to store data when possible. Objects used on tables are frequently flipped to access information as well. This use of 3D can be useful for aiding memory. People also use the third dimension when communicating with others. This mechanism of communication requires a large amount of freedom in how people manipulate the object, yet does not interfere since the interaction is natural and seamless. Our eventual goal is to leverage the rich 3D interactions available on physical tables on digital ones. We begin to move in this direction with the first step of exploring different techniques for interacting in 3D on digital tables. The first technique requires only a single finger for interaction, and so can already be used on a wide variety of existing hardware. To translate objects, the user grabs the center of any face and moves along the surface. To rotate objects only in the plane, the user grabs just outside the center and moves along the surface. This invokes a rotation and translation mechanism in 2D known as RNT. To rotate objects in the entire space, the user grabs anywhere else on the object and moves. The object will then follow the finger as if a weight at the object's center is providing some resistance. The second technique requires 2 points of contact and makes use of a finger on both the dominant and non-dominant hand of the user. To translate objects, users grab and move the center of any face as before. To rotate objects only in the plane, users can now grab anywhere outside that center. To rotate the object in space, while touching the object with the dominant hand, the user drags a finger on the non-dominant hand along the surface of the table. The third technique requires 3 points of contact and makes use of both the index finger and thumb on the dominant hand, as well as a finger on the non-dominant hand. To translate objects, the user can grab and move anywhere on the object with the index finger on the dominant hand. To rotate objects in the plane, the user can twist the object using both the index finger and thumb of the dominant hand. To rotate objects in space, the user can use the non-dominant index finger as before. To compare these 3 techniques, we performed a user study in which participants performed 3 different tasks. In the first task, users were asked to pass a cube with a specific side face up to a virtual user. In the second task, users were asked to dock a tetrahedron inside another tetrahedron. In the third task, users were asked to assemble a 3D puzzle made up of many tetrahedron-shaped objects to make a larger tetrahedron shape. The study suggested that when users use the one-point technique, they tend to make most use of the corners of the objects to rotate in space. We provide a modified version of the technique. To translate, users can grab the center as before. To rotate in the plane, users can grab anywhere outside this center. To rotate in space, the user now grabs only at the corners. We also present an alternative way to make use of 3 fingers on the table. Using this method, users provide a state change by touching with 2 or more fingers. The first finger provides 3D rotations as the one finger interaction did before. The user can stabilize this motion by using the thumb. The user can in this way restrict the motion to planar rotation. The user can further stabilize the interaction by touching the table with the non-dominant hand. This will cause the object to only translate when moved with the index finger on the dominant hand. Users can perform this final stabilization by either using a single finger or their whole hand. Note that with this new 3-finger technique, the point touching the object always remains under the user's finger. This can be beneficial for maintaining awareness in a multi-user environment. In summary, we provide 5 new ways of interacting with 3D objects using a direct touch tabletop display. These new interactions begin to allow the freedoms typically available on physical tables, including flipping of objects, storage, and communication with others at the table.